Hello, everybody. We're ready for the big finish. Here we go. We're going to name this monosaccharide. Now, what's going on here? You don't like the way it's drawn because it's a chair? Well, why did we learn chairs in the first place? It was so we could study sugars. Remember, all these bonds, either axial or equatorial, it doesn't really matter, axial or equatorial, except for things like stability. All it matters is up and down, up and down. So what do we got? We got down, up, down, down, down. You don't like it drawn that way? Why don't you do it this way on your own? And there's the O. Here's the next carbon. It's got a OCH2 phenyl. Next carbon over has an up NHAC. Yes, that's an AC. Acetyl. Oops. AC. Acetyl. And down OH. And another down OH. And a down CH2OH. And when we're finished, we're going to have to rotate that CH2OH back into the loop so we can have the fissure. Yeah, we're undoing the things we did. So I'll do one step at a time. So this used to be the anomeric position. I'm just opening the ring and getting rid of the acetal group. And then I have to rotate so it's a fissure. I need to have a fissure so that I can look at the fissure to tell what this is. So get the C back into the loop. That's the reason we had to do this, is to get the C back into the loop. So that goes CH2OH now. We have NHAC. We have OH. We have OH. We have, oh, this is an L sugar. How do I know it's an L sugar? Up, left. Left. So that translates to this right here. Up left, down right, up left. Up left, down right, up left, CH2OH. You're not going to find that one on the handout. You're going to find its mirror image. And you won't find any NHs. It's all OHs, right? Well, you know what to do with the N. You just change the name. So it goes, here's the L version. Here's the D version, the mirror image. And left, right, left is now right, left, right. And I got to find right, left, right on my handout, page 3. Time's ticking. Was it page 3? Hope so. No, it's page 2. Right, left, right. Right, left, right. It is galactose, D-galactose. D-galactose. Therefore, this is 2-acetamino L-2-acetamino galactose. And that will show up in the name up here. Oh boy, it's getting too big. Ready for the name. All right. Question 1. Is this O cis or trans to this CH2OH? Cis. Beta. Oh, that's not even the first part of the name. First part of the name, benzyl. What? Oh, if it's a acetal with a group on the acetal oxygen, name the group first. Sort of like naming esters, isn't it? So that's the benzyl. Phenyl with a CH2 is benzyl. Benzyl, beta L2 acetamino, L2 acetamino galacto pyranose. Side. It's not, it's got, that's the final answer. Final answer. Sorry, that's a lot of highlighting. Pyranoside, ring size 6 with an acetal oxygen. It's a diether. Side, acetal. It's an L sugar because this OH is on the left here in the open form. It's got an acetamino group. You could also call it an N-acetylamino or N-acetylamino. That's more UPAC. This is a condensed version of acetylamino. I put that quotes here. Takes the place of that. Galactose, because it was a galactose sugar, did all of our unraveling. So we got to here, then we had to find this, and then we started going backwards and named our thing here. And hopefully I didn't lose too many people. We'll try to get you back on the next one. Our original question. Time's ticking. Okay. You're going to practice on these. The top sugar, you're going to end up here. And there's the anomeric carbon right there. And the next one is down, down, down. 3 downs in a row. Left, left, left. Right, right, right. Sorry. I don't even know my own short form. Down, right. Not. Never mind. Down, down, down. Right, right, right. And, whoa. All of them were down right. So in my mind, I've done this decades now. In my mind, I had to rotate the CH2OH back into position. CH2OH had to end up here, and the O therefore got rotated down here, which is right. And the CH2OH is here, and the H is there. And a little reminder, undoing the ring. And this is 3 acetamino D-allose. How did I do that without looking at the handout? On the handout, the name allose actually says where the groups are. They're all on the right side. Just look at your handout. It goes OH, OH, OH 4 times on the right side. You can call it allose to help you remember, but you don't have to remember. You've got a handout. And the bottom one was a ketose. Similar story. You got to get the CH2OH back into position. It'll be on the right side. Because when the CH2OH rotated to where the O is, the OH rotated down there, and the H ended up here, up lefting. And in the middle, carbon 2 is this one. Yeah, it's a ketose connected to carbon 1 of an aldose. 3, down right, up left. Down right, up left. Down right, up left. Isn't that right, left, right? Wasn't that sorbose? Do I have time? I have time. Slow down here. Page 2, apparently. Right, left, right. Ketose. 6 carbons. Right, left, right. Desorbose. But that's not the name of the disaccharide, is it? Up on top, the anomeric O is this O. How do I know that's the anomeric position right there? Right there? It's the only carbon bonded twice to oxygen. All other carbons were just alcohol carbons from the original sugar. How do I know this is the anomeric carbon on this sugar? It's the only carbon bonded twice to oxygen. Once, twice. That's the carbonyl from before. This was the carbonyl from before. Now it's an anomeric position. And carbon 2 there. Carbon 1 is this one right here. And so when you're naming it, you've got to have a 1 that's alpha or beta. O down, CH2OH up. Beta on 1 is connected to the other anomeric position where this is up. Did I say beta is what? Forgetting my own definition of alpha and beta. The O is trans to the CH2OH. Is that alpha or beta? Trans. Alpha from 1. The O is cis down here. The O is cis to the CH2OH. That's beta. 2. There's a linkage that's worth a point in the middle of the name. This is the middle of the name. I want the sugar here, and you could even, write the word with here. I don't know, just write the sugar. 3 acet amino D-allo. How do I change the name at the end? 1, is it a pyranose or a furanose? Ring size 6 is a pyranose. Now, is it a pyranose or a pyranoside? Is this a hemiacetal or an acetal? If it's a hemi, you go os at the end, O-S-E. It is not a hemi, it is a full acetal. It ends with oside. And then the other sugar is D-sorbo. Is it a furanose or a pyranose? It's a furanose, ring size 5. Is it a furanose or a furanoside? Go to this carbon. Is it an acetal or a hemiacetal? It's a geminal diether, acetal. Acetals end with ocide. There's your final answer. And that is worth 6 full points. And today was a big day about drawing cyclic sugars. We should be able to draw any cyclic sugar anytime and name any cyclic sugar anytime. And that brings to a conclusion today's lecture. And I look forward to seeing you all on Wednesday. Take care.